Good evening, class, and welcome to our MI lectures for today. Let me share my notes so that we can continue from where we stopped the last time. Okay, so if we remember on Monday, we had session 7. Session 7 was all about forecasting. Wonder why this thing is stiff. Give me a moment for, okay, let's move it now. All right, so we started with forecasting as a topic, and we did part 1 last time. We said at the end of the topic, we should be able to construct a time series. We are going to identify and draw the trend line. Then we are going to derive a line of best fit using centered moving averages or least square linear regression analysis. That was where we ended in part 1. And so, if you could remember, we came across these formulas for time series model. For the additive model, we said this time series is TS, that's time series, which is T plus S. Look at the second one here, T plus S. This TS here is time series. The T here is the trend or trend value. The S here is the seasonal variation. We'll be looking much more of this formula in this class. Then look at the proportion here. The proportional or multiplicative model, we have TS equal to T multiplied by S. So we told us why the C and the arrow are not in use. We explained that. Now we looked at the histogram of time series. So look at the scatter diagram, and this line is the best line of fit that goes through the scatter diagram. So we also looked at the two types of, the two aspects to analyzing a time series from historical data. We said that we will do what they call estimating of trend line. Then we do what we call seasonal variation. So the last time we took just the trend line, and we can use two ways to calculate the trend line. We have the moving average method and the linear regression analysis. Now in the moving average method, we said we'll decide the length of the cycle. When we decide the length of the cycle, it means that a complete cycle for 1 week could be 5 days, it could be 7 days, depending on what you have in mind. So that one cycle is called a season. Now, after you do that, you use the historical data, which is the historical sales figure, to calculate the series of moving averages. So what you do is that you add up all the sales data that form one circle. So if there are 5 days, you add the first 5 days and divide by 5 to get the average of these 5 data. Then you move the average by removing the first item in the data. So it's now becoming 4 now. You will now add one more under it to complete the circle. So if you are removing Monday of week 1, you are adding Monday of week 2. So every day of the month, of the week, is always represented. You find another average. That is how you do it. So you keep moving the average until you get to the end of the data. You find out that when you find the average, it will correspond to a particular day, if it is days, or particular quarter, if it is quarter. But in the meantime, you can only achieve that when you have odd number data that you are using. For example, 3 days, 5 days, 7 days, moving average. All these are odd numbers. You can achieve that. But when you have even numbers, let's say 4 quarters, 4 weeks in a month, 12 months, the circle that make up one complete season, if it is even, then you go to step 3 by calculating average of the average. So you look at 2 average that do not fall in a particular line or particular quarter or day. You find the average and put the average to correspond with a given period. So when you do that, you use the moving average and their associated time periods to calculate the trend line, which is what we did in example 1. We used it to calculate the trend line. And this daily sales here was our trend line. This daily sales is like saying Y equals to 78 plus 2x. So this was our equation of trend equation. So we can now use this to forecast. And we said we want to forecast for 50 days, for day 50. What would that be? And we said it's 178. Fine. Now, this is one way in which we make forecasts. We said we make forecasts using trend line. Trend line, which we got from moving averages. Fine. So that's the first one. But we are going to make it look more realistic by including what we call seasonal variations. So the seasonal variations will bring peculiarities for each day you are taking into consideration. Let me give you an example now. You know, in Lagos, if people are going by public transport, you know that on Fridays, there is always a rush coming back home. That's a peculiarity of Friday. Then on Monday morning, there's always a rush going to work. Peculiarity of Monday. So you take into account the peculiarities of each day. That is the seasonal variation. So what you expect, the transport you keep, if you are using transportation, the transport you keep on Monday morning and on Friday evening is based on the peculiarities of those days. So in example 1, we did for odd number. In example 2, we saw the same thing using even numbers, and we applied that step number 3 to ensure that even numbers are aligned to a particular period that belongs to it by doing an average of average. Okay, then we now use the high or low method to get the line of best fit. And I told you that I prefer you using the high or low method every time to get the line of best fit. Okay, then we now went ahead to do the least square linear regression analysis, and we did that in example 4, and we saw one formula, one nasty formula that will be given to you in the exams. You know how to interpret this formula. The n here means number of observations. Here it's 12 because we are given 12 figures. You can see them here. X is 1 to 12. Fine. Then you saw how we got sigma. Sigma is a summation of x, y. So you must have a data for x, y. We have x already. We have y. So you bring that of x, the sum of x, multiplied by the sum of y to get this figure. Then you bring that of x square. We have to get a data for x square. Find all the sum of x square, which is this 650 here, multiplied by 12, which is the number of observation. Then we have sigma x, then square. So this is sigma x squared. We said that b is gotten first before we get a. So in the equation, if they give you a first, then b under, do the b first because b will be useful here in getting a. If you start with a, you'll be having two unknowns. So if you start with b, you have only one unknown. Okay. Now we compared that the line of best fit using least square method. You start from 1 and there is no data loss. When you go to centered moving average, okay, you see there is no data loss. But when you get to centered moving average, there is data loss, especially at the beginning. And so when you want to predict using centered moving average, everything is in relation to where this started. And this where this started is 0. It's called, like, it means that here is 0. All this 1, 2, 3, 4, 5 means up to 13 here means there are 13 quarters between quarter 4 year 4 and quarter 3 year 1. That is what it means. There are 13 quarters. But here, you don't need how many quarters are in between. So you just take what's x and you multiply straight. So these are the two things that you can see the differences. Now we said that in our next class, we will take up the additive model to make forecasts, and we'll use the proportional model to make forecasts. Okay, so let's see how we can do that now. The trend line on its own is not sufficient to make forecasts for the future. So in part 1, when we did our trend analysis for 50 using example 1, and we got 178, it is not enough to just get 178 because we need to estimate the size of the seasonal variations for each of the different seasons. We said that these are the peculiarities. We need to account for the peculiarities. Now, consider the two examples above. In the first example, we need an estimate of the amount of the expected daily variation in sales for each day of the week. That's it. In the second example, we need to calculate the variation amount above or below the trend line for each quarter or season of the year. So you see, whether we are using odd number or we are doing even number, once you've gotten your trend line, the next thing you should do is seasonal variation. So I will give you something that will help you to remember that once you do your trend, you do your seasonal variation. Now, a seasonal variation can be measured from historical data. What is the historical data? That's your actual sales figures that was given to you week 1 to week 3, or quarter 1, or year 1 to year 3. All those ones are historical data. Now, your seasonal variations is the difference between the actual value for the time period and the corresponding trend value. Let me explain what I mean here. Let me go to this place, page 12, and show you what I mean. Now, okay, let me go back up once. Okay. Now, if you look at your trend in this question now, look at the actual. Let's go to quarter 3. Okay. Let's say quarter 4. This is 27 here, 31 here. This happened to be your actual. And now, taking it straight, this is your trend. So the difference between 31 and you will now say 31, which is the actual, minus 31.13. This is the variation, seasonal variation for just quarter 4, year 1, quarter 4. So that's what we are trying to say. Okay, you will see in the example when we do this example. Now, the seasonal variation is then used to adjust the value we got for the trend analysis. Now, there are two models we can use to estimate the seasonal variation. One of them is the additive model, and the other one is the proportional or multiplicative model. Now, let's look at the additive model. Now, from the name additive, you know, it's not addictive, additive. Additive means that you have to add. Fine. This model assumes that seasonal variations above and below the trend line. When you look at those histograph, the line of best fit, you know there is a straight line, there are some figures up and down. So it assumes that that one is the actual data. Then, but that line of best fit is the trend line. So what they are telling us is that the actual line minus the figure on the straight line, the actual data minus the figure of the straight line is what gives you your seasonal variation. So it says that it assumes that the seasonal variations above and below the trend line in each circle adds up to 0. What it means is that for one circle, if we are saying is Monday to Friday, the seasonal variation of Monday plus the seasonal variation of Tuesday plus the seasonal variation of Wednesday, Thursday, Friday, if you add them together, you should get 0. That is what it means. So because it's a circle, let me illustrate now. It's a circle. Okay, let me go up. Okay, this is page 9. Let me go to page 4. I'll come back to page 9. Okay, page 4. So you can see that it comes here, goes up, comes, goes up, comes, goes up, comes. Maybe here might be the end of a circle. So it may have started somewhere around this point and end somewhere around this. Or look at it, it started from here and goes up, down, maybe ends here, one circle. You see, if you are adding all the variations, it should give you 0. That is what we are saying. Okay, seasonal variations below the trend line would have a negative value. Yes, it will have a negative value because the actual is going to be lower than the trend. While those that are above the trend line, we have a positive value. Let's go back to page 9 and let me show you something. So if you go to page here, you see that this 20, okay, let me go down again. Okay, now this 27 here is below the trend line. So it gives you a negative figure because you have to say 27 minus 27.38. Now, this 44 is above the trend line. So this is going to give you positive. The same with this, giving you positive. So that's what we are saying. Okay. Now, the seasonal variation for each season or daily variations for each day is estimated as follows when the additive assumption is used. Now look at it. Calculate the difference between the moving average and the actual historical figure for each time period. That is what we call seasonal variation for each day. Now, group these seasonal variations into the different seasons of the year. We'll see how we'll group them. Then calculate the average of this seasonal variation for each season. That means if I have to interpret number 2 here, all the seasonal variations, if it is day, all the seasonal variations that belong to Monday, you group them together. All that belongs to Tuesday, you group them together. All that belong to Wednesday, like that. Now, you now find the average of each. So for that of Monday, if there are 12 observations, or maybe there are 3 observations grouped together, you add the 3 divided by 3. If there are 2, you add the 2 divided by 2. If there are 5, you add the 5 divided by 5. You get the average for each seasonal, for each season. Now, if the total seasonal variation for the cycle does not add up to 0, the difference is spread evenly across each season, day or quarter or month. So what we mean is that you find the average of Monday, find that of Tuesday, Wednesday, Thursday, Friday. When you add all those averages together, the assumption is that you must get 0. The cycle adds up to 0. So the average of Monday, Tuesday, Wednesday, Thursday, Friday should give you 0. But in the interim that they didn't give you 0, you have to find the difference between what you've gotten and 0. So that difference, either you are adding or you are subtracting, you do it across board. We'll see an example to see how we'll do it now. Look at example 5. Example 5, calculating seasonal variations using the additive model. If you recall, our example 5 is the same thing as example 1. It's the same example we are using. So the only difference between these 2 questions, example 5 and example 1, is that look at the required. Referring to example 1, where the trend line was gotten. So we will no longer be finding the trend line because we've done that in example 1. Calculate the seasonal variation values for each day. That's 1. And forecast the sales for Friday, week 10, day 5. That is day 50. If I can remind us of what we did here, we did in example 1, we only did the moving averages and we use it to forecast for day 50. So if you look at it now, we got our seasonal, we got our trend line, and we used it to calculate that of day 50, and we got 178. So if we have to stop at moving averages, trend line, This is what we'll be saying. 178 units is what we are going to do. But let's see how seasonal variation will change things. So if you look at this, the solution here says the seasonal variation can be calculated from the actual sales and moving averages as follows. Remember this trend line? There is TS and there is T plus S. So what it means is that your trend series must always come with your trend first. Then you do your seasonal variation. So this equation can help you know that TS is equals to T plus S. It means your trend will be gotten first, then your seasonal variation. Now you want to get your seasonal variation. It means you have to make seasonal variation subject of formula. So if S is the subject of formula, this T will move over here. So it will become TS minus T. So you see here, S is TS minus T. So that's why we said, if you want to get your seasonal variation for each day, you'll be saying your actuals, which is your TS, which is your actual, minus your moving average, which is your trend value. So this TS is as good as this. This T here is as good as this. So look at what we did here. Now, if you can remember from our answer for 1, this is just a copy and paste starting from day 3. So if you look at it, starting from day 3, where the sales here, look at it from day 3, sales is 89, yes, and we took the moving average 84, so that's what we're extracting. Then ending at day 13, where the sales is 109, seasonal variation is 104. So this is it. These are the two things we extract. So what we did here now was 89 minus 84. This is the workings here, gives you plus 5. So you do the same working here. This will give you minus 1. This should give you minus 3. The next one will give you minus 2, down to plus 5. Now you have calculated the seasonal variation for each of these days, moving in the trend. So the trend determines where you start. So if the trend starts from day 3 and ends at day 13, that is what you bring to the table. Now that you've done this is the first step. The next thing to do is to group them. The seasonal variations, that's the daily variations, is now calculated as an average of the seasonal variations for each day. So look at what we will now do. We'll arrange it again. We know that our day 1 is Monday. Day 2 is Tuesday. Day 3 is Wednesday. Day 4 is Thursday. Day 5, Friday. That will mean that our day 6 will still be falling on Monday. Day 7. So even if we didn't write days like this, day 1 to 4 and all that, and we put Monday, Tuesday, we know that it corresponds to all of this. So this is day 3. So day 3 fall on Wednesday. So this plus 5 here is the same plus 5 here. Day 4 is minus 1. You take it to the next day, Thursday. Friday is minus 3. You bring it down here. Then Monday is day 6. You bring the figure. Tuesday is day 7. You bring it. Do that for the second week. Then the third week, we have day 11, day 12, and day 13. So it's day 11, day 12, and day 13. Now that you've done that, you look for the average. The average of these two is to add these two and divide it by 2. So let's do it together for the benefit of doubt. Minus 2 minus, minus 2 minus 2 will give you minus 4. Now divided by 2 observations, it gives you -2. So the same thing with this, the same thing with this, the same thing with this, the same thing with this. So now the thing we are saying is that it is the average we are going to be adding together. So -2 plus 1 plus 5 minus 1 minus 3. You see, it's giving us 0. So the average total in each circle is 0. So look, we're not adding this to this to get 0 here. Neither are we adding this to this to get 0. Although if you do it here, we'll give you 0. And we're not adding this to this to get 0. What we are interested in is the average. So we have averaged everything. So these 2 here represents everything of Monday. This one represents Tuesday, like that. You add everything, you are the complete circle, add them up together, it's giving you 0. Once you've achieved that, that is a big step. So what do you do next? You come and make your prediction. Now look at your forecast. In the first time we did the forecast, we said using the trend, we got 178, right? This is the same thing. How we did it and got 178 is what I brought down here. So the trend line was this formula, and we got it as 178 for day 50. Of course, our day 50 happens to be a Friday on week 5, on week 10. It's a day 5 figure. It's day 5 of week 10. So you to be under week 10, under day 5. So all you'll be looking at is, you'll be thinking about day 5 figure. So week 10, day 5 is where you will see your day 50. So look at what we'll do. From our trend analysis, which we got from example 1, we got 178. Now, additive seasonal variation means it's either you add or you subtract, whichever is the figure. So look at the seasonal variation for day 5. Look at this, our example 5 we are doing now. Seasonal variation for day 5 is -3. So you're going to add -3 to 178. So it gives you 175. So it means that the sales forecast for day 10 week 5, which is day 50, is approximately 175. So this is make it more realistic. If you have just taken 178, you didn't put in the peculiarities of day 5. You didn't put in peculiarities for day 5. It's just like saying, okay, I want my normal transport from maybe Oshodi to Island, let's say to Balende. You usually pay 300 naira, and maybe on a Friday that is a rush day, you didn't take the peculiarities of Friday that you have to pay extra 100 naira or maybe extra 150. That is what this is about. Or maybe you didn't take the peculiarities of maybe on a Tuesday or Wednesday or Thursday that there may be no rush, that they may want to give a discount. So that's why trend value alone does not stand. You must put the seasonal variation. So this 175 units is much more accurate. It's still an approximate value, but it's better. Now let's look at example 6. While we are doing example 6, the first one was when we tried to look at example 1 to forecast. Let's look at our example 2 and do a forecast using additive model. Once again, we are doing the same thing. This question is the same thing of we got in example 2. The only difference is the requirement. Now we said referring to example 2, where the trend line was gotten. Calculate the seasonal variation values for each quarter and forecast the sale for year 4, quarter 4 using the additive model. Remember, in example 2, we forecasted the sale of year 4, quarter 4. We did a forecast of year 4, quarter 4. Where is that again? Okay, we did a forecast for quarter 4 in year 4. This was the trend line we got using the high or low method here. We got a trend line. We use it now to forecast that of year 4, and we got 78.86. This is in thousand. Okay, so now let's see how we can do it using additive model again. I'm going to show you something that you may likely see. Now, once again, we bring our quarter. This is our trend. In that first example I gave you, your actuals was here and your trend was here. It doesn't matter where it is. All you need to do, is your actual minus trend. Actual minus trend. So you might see trend here and you see actual here. It's deliberate. Now you can see, you will not say your trend minus your actual. If you look at this equation, to make S subject of formula is TS minus T. So this is your TS, this is your minus T. So it's going to be 27 minus 27.375. You're getting minus 0.375. So here, the last one is 47 minus 46.875, and you're getting 0 points. So anytime the actual is bigger than trend, you have a positive number. Anytime the trend is bigger than the actual, you have a negative number. Now that we've gotten our trend for trend analysis, which we brought here, brought your quarter actuals, you've gotten your seasonal variation. The next thing to do is to group them. So the grouping now is quarter 1, quarter 2, quarter 3, quarter 4 grouping. So look at how the grouping is done. This is a quarter 3 figure. So you see it's starting in quarter 3. This is a quarter 4 figure for the year 1. Now going to year 2, quarter 1 is here. Year 2, quarter 2 is here. Year 2, quarter 3, and all that. So if you do everything here, well, you get all the quarters in line. Now what do? You find the average. How do you find the average? We will say minus 0.125. So there's a minus here again. So you say minus 2. Give you minus 2.125. Now you divide it by 2. You see, minus 0.1 minus 1.0625. Here it has been approximated to 0 minus 1.063. You can put all the figures if you like. You can put the approximate. Depends on what you want to do. The same thing you do here. The same thing you do here. Now in the case of this one is giving you 0 because they are two the same number. Now, when we do the average, the first one is minus 0.0625. Let me approximate it to what they did. Okay, I've approximated it to what they did here. Now, you now plus 0.313 plus 0.313 plus 0. You see, you are getting minus 0.437. But what are we supposed to get? 0. So we're not supposed to get minus anything. That means our 0 is bigger than this. So we need to add something to this to make it 0. We need to add something to this to make it, because our answer is in minus. If your answer is in positive and it's not 0, you need to less something from it to make it 0. So what are we going to add to this to make it 0? It's the same thing, because if I say plus 0, it's going to give you this. Or if I say minus 0, it's still going to give you this. So you are going to add this same number to make it 0. If I tell you that I have minus 5 as my answer, and I want to achieve 0, how do I achieve 0 from minus 5? All I need to do is to add 5. If I have plus 5 and I want to achieve 0, what do I need to do? I will say minus 5. So we have minus 0.437. We want to achieve 0. What do we need to do? We add itself. So what do we do now? So that is this figure here. So you do left to right. So this figure, you add it now, because when you add this to this, you see it's going to give you 0. So you divide this figure, which you are adding, by the number of observations. So you're going to divide it by 4. When you divide it by 4, can you see that everything will give you 0.10925? You put all the figures. So it is plus, so not minus. So you put the same figure, you are putting them across board. Everything across board. So what you will now do is, this is what we call adjustment. It's called adjustment. So how do you do it now? So the first one you got was minus 1.063. Sorry, minus 1.063. Now you are adding 0.10925. You see, you are getting minus 0.95375. That is how you do it here. The same thing, you add these two, you get your seasonal adjustment. You add this, you get seasonal adjustment. You add this, you get seasonal adjustment. Now, if you are to add all of these together, you are getting 0. So let's try it. This is already on the board there. We'll now say plus 0.42225 plus 0.42225 plus 0.10925. 0. So your answer is 0. So you have successfully made each complete circle to be 0. Now that you've done that, this is what you'll be looking at as your seasonal variation. So we want to do a forecast now. The forecast is for quarter 4. The season for quarter 4, year 4. So now that you've known that it is quarter 4, what you'll be looking at is this seasonal variation here in quarter 4. So all you'll now do is find the trend value first. The trend value we did with high or low method, we got it to be 78.86. Fine. That is this 78.86 is in 1,000. Now, bring the seasonal variation of quarter 4. Quarter 4 seasonal variation is this. It was rounded up to 0.11 to make it 2 decimal place. So you can round it up. So it was brought here and rounded up to 0.11. When you add it with this, sorry, it was not aligned here. You add it with this, you are getting 78.97. So you see, seasonal variation, look at the forecast, is the T plus the S. It means your trend plus your seasonal variation. So you've gotten your trend first, then you get your seasonal variation. You add them together, you are getting it. So the forecast is 78,970. taken into consideration, this 0, 0, 0. So this is your additive model. So the first thing to do is get your seasonal variations by saying your actuals, which is your trend series or time series, minus your trend value, which is your moving average. You get the seasonal variation for each day. When you do for all of them, you now group them according to each day in the season. Day 1, day 2, or quarter 1, quarter 2, or week 1, week 2, as the season goes. Then you look for the average. When you look for the average, add them up together, add the average up together. It must be 0. Must be 0. Must be 0. Now, when it is not 0, look for the difference that should make it 0. If it is more than 0, it means you have to less something to get 0. If it is less than 0, it means you have to add something to make it 0. That thing you're going to add or less, share it across board and get your seasonal adjustment. That seasonal adjustment will give you exactly equals to 0. Then you come back again to make your forecast. The forecast you made using your trend, you will now adjust it with the seasonal variation. That will give you a better forecast. That is how people who are doing weather forecast, currency forecast, they apply all of these. Okay, now that we've seen seasonal variation additive model, let's get to the proportional model. The proportional model is the multiplicative model. Now, this multiplicative model, like the name implies, you have to multiply. The difference between additive model and multiplicative model is the method. One of them you have to add. You have to add your seasonal variations to your trend to get your forecast. But in multiplicative or proportional, you multiply your seasonal variation with your trend to get your forecast. That's the difference, number 1. Difference number 2, when you are doing your average, when you add them together, it will not give you 0. Now, the average will follow this pattern. If you did a 5-month or a 5-day moving average, if you did a 5-day moving average, it means that if you are using proportional model, your average must be equal to 5. If you do a 4-quarter moving average, your average must be equal to 4. That is how we'll do it. And if there is a difference in how the average was gotten, maybe you're supposed to get 5 and you get 5 point something, we do the same normal way, you find a difference and share it across board. So the pattern we are doing for proportional model is the same pattern with additive model, but for just 2 differences. 1, the average will not be equal to 0. It will be equal to the number of items that make up a circle. Secondly, your forecast is done using multiplication. So you will not be seeing things like plus or minus. You'll be seeing things, your seasonal variations will be either more than 0 or less than 0. Either more than 0 or less than 0. Sorry, they are all going to be more than 0, sorry. Either more than 1 or less than 1. They are going to be more than 0, so you will not get negative answers. but you're going to be getting 0 points because it's a proportional. You're going to get 0 points, positive 0 points, positive 0 points, or you're going to get 1 point. Why are you getting 0 points? This is because your trend, your actuals might be lower than your trend. You get 0 points. Why are you getting 1 point? Because your actual was more than your trend. Now, another thing that is different is how you calculate your seasonal variation. In the case of additive, you were saying that the seasonal variation is equal to time series minus the moving average, right? But in the case of this one, seasonal variation is time series divided by trend value. So you see your minus in the additive is replaced by division in your seasonal variation, in your proportional. Now let's look at an example now. This example 7 is the same thing as example 1. Now, remember our example 5 was the same example 1, while we did with proportional additive model. So let me just bring that example 5 because we'll be comparing with example 7. Go to example 5. Sorry. Example 5. So we'll be comparing notes with example 7. Now, we are told that we are going to be doing the same thing using the proportional or multiplicative model. So what do? We don't need to do example 1 again because we've gotten our trend using example 1. After getting your trend, because everything, if they ask you to do this, you must do everything you did in example 1 to get your trend. After getting your trend, you will start doing this. So you see, your sales and your trend value are all here now. So remember this formula, TS equals to T times S. If you want to make S subject of formula, this T will move to here and it will be division. So it will be TS divided by T. So that's what we are doing now. 89 divided by 84, you are getting 1 point something. So I did mine to 4 decimal places. You are dividing. Anyone that the sales is lesser than moving average, you see them is 0 point something. So it is between 0 and more than 1. It depends on how dispersed your figures are, but it will not be less than 0. So looking at all of these that you've gotten so far as your seasonal variation, you are now going to group them as usual. So we will now do a grouping. So look at this grouping now. All the trend for day 1 are brought under here. For day 2 are brought under. So you'll be very careful. Day 3, day 4, day 5. Then you now find the average. You add these 2 divided by 2, you get this. Add this 2 divided by 2, you get this. Add this 3 divided by 3, you get this. Add this 2 divided by 2, you get this. Add this 2 divided by 2, you get this. Now, when you add all of these averages, it is giving you 4.9995. What's the difference? You are supposed to get 5 because we did a 5-day moving average. And you look at it, there are 5 groupings, 1, 2, 3, 4, 5. Unlike additive model that you must get 0. Here, because there are 5 groupings here, you have to get 5. So what's the difference? What will make this to become 5? Just to add 5 here. So it is going to be 0.0005. If you add it together, you are getting 5. Now you have to divide this number into 5. So you are sharing it equally. So because it's a positive number, you are adding. So when you add these 2, you get this. add this, you get this one here. You add this to this, you are getting this here. The same thing you are doing for Thursday, the same thing you are doing for Friday. So if you want to test it out, you add this circle here down to here, you are getting 5. Don't just assume that because you've done it here, you get 5. To be sure that what you've done is correct, you add them. If they give you 5, that means you are correct. If they don't give you 5, that means you have done something wrong. Now you now make your forecast. Our forecast is for Friday, day 5 in week 10. So look at Friday, day 5, week 10. You'll be looking at this figure here. So what do? We'll go to our trend line, which we got before, 178. If you remember, we got 178. Now look at our seasonal variation for day 5 is this figure here. So when we multiply this one by, because it is multiplicative model, it is proportional. That's why you're saying 0 points. Proportional. When you multiply it by this, you're getting 172 units. Now, when you compare additive model, you're having 175. You're comparing with multiplicative, you're getting 172. Note that your trend is still the same in both values. So your trend is going to be found whether you are told or not. Once they ask you to do multiplicative or additive, look for your trend first, because you use it so that the method of seasonal variation will determine whether it is going to be multiplication or addition. So you've gotten your 172 here as your number of units for the week, for the day 5. So what it means now is this, is how to interpret now. It means that for every day 5, you are forecasting that you will make approximately 172. Now, your forecast could be correct, it may not be correct. Let's look at some day 5 figures here to show that it might be correct, it may not be correct, but it's just a forecast. So this was our example 1. Let me go to page 5 or page 6. So our day 50 was said to be 178, okay? So if you have continued the progression, you find out that it will get to that point where you get 178 or 172. Okay, let's go to the next example, which is going to be the last one. We are using our example 2 again. You know, in example 7, we did example 1. Example 8 is example 2, but we have changed the method to multiplicative. We do the same thing here. We do the same thing we have been doing before. I told you that you can put your trend here and your actuals here, but know that it's going to be actual divided by trend. That is what you do to get here. Actual divided by trend, you get here. Actual divided by trend, here the same. Here, actual was more than trend, you are getting 1 point. So when you finished, you now group them together. When you group them together, look for the average. Add this to divide by 2, like that. Add them up. You find out that here is less than 4, but we need 4 because we have 4 quarters, 4-quarter moving average. So what will make it 4? You find the difference between 4 and this, you are getting this figure, which you will not divide across, no, divide by 4. So you are getting the same figures all through. So you will now add them up, add them up, add them up, add them up, because they are plus. If it was minus something, you'll be lessing them, lessing them, lessing them. So by the time you add all of these, you are getting 4. So your forecast will now be as follows. Remember, your trend was 78.86. Fine. That's your trend, 78.86. Now look at your quarter adjustment, quarter 4 adjustment. Look at your quarter 4 adjustment is 1.0027, approximated to 1.003. So we look at it here, times 1.003 rounded. When you multiply, you are getting 79.01. 79.01 as against, let me go here, additive model. Let me go to page 19. As against additive model, as against 78.97, 79.0 as against 78.97. So you see, you can either use each of the model. So the question in the exam will ask you which model to use. These questions can come up in objective, why they can give you moving average, they can give you everything, and they say the following data will be used for question 4 and 5. They will now play with figures. So far so good. We have looked at the use of additive models to make your forecast. We have used proportional model to make forecast. Once again, let me reiterate the steps. First, you need to look at how many periods make up one season. Secondly, you need to know whether there are even number of periods or odd number of periods making up a complete cycle. Thirdly, you look for the trend by following the steps to look for moving averages. The average keep moving as you go along, keep moving. By you removing one previous to add one later. Keep doing that. You get your moving average, that is your trend. Now use your high or low method to get your equation of trend line. That's your trend equation. Use the trend equation to make a forecast, a preliminary forecast, which you will keep. Then go back, compare your actuals with your trend. Now, if it is additive model, you're going to be saying actual minus trend, actual minus trend. If it is multiplicative, you're going to be saying actual divided by trend, actual divided by trend. Now, whatever you get as a seasonal variation, you group them according to the periods. When you group them, you get the average. Now, when you get the average, sum the average. Now, if you are using an additive model, when you sum the average, they must be 0. If they are not 0, make adjustments to make it 0. If they are multiplicative, if you sum them, it has to be number of periods that make up a circle. So if you have a 4-quarter moving average, the total will be 4. If you have a 5-day moving average, the total must be 5. If you have a 12 months moving average, the total must be 12. If they are not, make them to become that value by making adjustments. When you make adjustments, you have gotten your seasonal variation for each that you'll be using for general purposes. Then you forecast again. You bring your forecast you got from your trend analysis. Then whichever seasonal variation you are using, additive, you either add or subtract according to the seasonal variation of the day it corresponds to or the period it corresponds. If it is multiplicative, you multiply by the proportion of that day or period given to you. That is your forecast. This topic is very simple, but you need to be very careful so that you do not get confused. This topic would have been treated in totality by last class, but I just don't want to bog your head down with everything because you need time to digest it. So this is the part 2, the end of the part 2. So go home now, look at questions from past questions that has to do with forecasts. You will see 1 or 2 or so in the objective part. You will see a few too in the theory part. Try your hands on them and see how you can master that topic. I don't have question trend for MI, working on it. If not, I would have checked to find out questions that you would have worked with. At this point now, I want to find out if you have any question that we can discuss. From the chat, I can't see any question. So our class is going to end with this topic. So I want you to take the time to practice. If you have any question now, I'll give you like 1 or 2 minutes to see if you have question. If you don't have, by the next 2 minutes, we'll end the class. If eventually you have a question, you can come to the WhatsApp group and ask your question, or you ask me the question privately. Okay, sticking. Next 1 minute, if there is no question, then the class will end. Meanwhile, I want to commend you for being punctual today in coming to class. It's a good thing. So you have extra time now to do some practice work. And also, if you look at all the other topics that we have discussed that you still find difficult, feel free to ask any of your lecturers who have taught that topic to you, so you can understand and move forward. Our next class will be on Monday. So you have Thursday, Friday, Saturday, and Sunday to review and digest everything. I'll see you in the next class. Thank you so much and have a nice day.